To explore a new concept called a density curve, we're going to start by looking at a histogram of data collected from Clucky's chicken farm in March 1998. A little caveat to this is I totally made this data up. There is really no such thing as Clucky's chicken farm, but we're going to use this as an example. So in this example, there were 101 chickens looked at, and we looked at how many eggs that a chicken laid in a month, and this is our distribution of relative frequency. So, for example, if we look over here, about 20% of the chickens laid between 24 and 28 eggs per month. So we see here that the mean is 22.02 eggs, and the standard deviation is 8.4 eggs per month. Now the first question is, what percent of the chickens on Clucky's chicken farm laid, it should be laid, by the way, I found that out, laid between 12 and 24 eggs in March 1998. We actually Googled this to make sure it was the correct past tense for laying eggs. So between 12 and 24, we have a bar here from 12 to 16, from 16 to 20, and from 20 to 24. So remember that if I were to count up everything in this bar, on all three of these bars, and add them together, then that would be the total percentage for between 12 and 24 eggs. So if we read over here, this one looks like it's about at 8%. And if we go over here, that one looks about 15, and this is about 19. So 8% plus 15% plus 19% equals 42%. Okay, so we're just adding up the bars. Now something just to remember is that if I were to add up all of the bars, the area under all of them together should be 100%. So the area of all the bars is 100%. So that's just something to keep in mind. Okay, the next one asks, what's the probability that a randomly selected chicken from Clucky's chicken farm lay 3 dozen or more eggs in March, once again laid, in March 1998. So it's kind of two different questions. This is asking what percent of the chickens were in these categories, and this is what is the probability that one randomly selected chicken laid this much. But we're still saying what's the probability. So we're saying what percent of chickens would be in that category, and that would be the probability of picking one of them. Okay, so what percent? Once again, we're looking at these bars now, 36 or more. So I believe that's 5 plus 2 plus 1%. So 5% plus 2% plus 1%, or 8% of the chickens were probably laying 36 or more eggs in March, in 1 month, in March 1998. Now, imagine if we took this graph now, this histogram, and we drew a smooth curve over it, kind of like this, to sort of represent the area. And notice how, I'm kind of smoothing off the peaks a little bit and cutting them off here and there, but giving the same basic area under the curve. This is known as a density curve. So what are some characteristics of a density curve? Well, number one, what we just said, well, a couple things we just said, is we use it to smooth out a histogram. So it represents the histogram, but without the jagged edges. Number two, the total area under the curve equals 1, or 100%. So just like the histogram, the area under the curve is the same. Number three, instead of counting the values and adding the bars, we now can use a mathematical function to find percentages and probabilities. Now you might think, well, what function is this? Well, it turns out if you go to the very end of your packet, last page, where there's a big summary of all the stuff about the normal model, and there's a little box in the bottom right hand corner, and I'll just show that to you really quickly. Just right down here. This is the equation of this curve that you are looking at. Now, are you expected to do any of the math involved with that curve? No, that's the good news. The only way to find the area under a curve like that is to use calculus, and this is not a calculus-based course. So I'm going to uses calculus, but we use technology. Okay, so the calculus is built in to the technology that we're going to use to find those values or those areas under the curve. But for those who've had calculus, you can recognize that as an integral. So if we were to answer those same questions that were asked above, what is the probability, or what percent of the chickens laid between 12 and 24 eggs, we would answer it by finding the area under the curve. So for question number 1, you look at the area, the area under the curve, right here. For question number 2, we would look for the area under the curve right here. All right. And instead of counting the bars, we're actually calculating an area under a curve in a mathematical function. Now, look at the box here. Notice we have the same numbers for mean and standard deviation as we did above, but now we have different symbols. So the first symbol, mu, which is the Greek letter, it's spelled like that, but it's pronounced like a cat says mew. That is the mean of the model. Now, why do we call this a model? A model is not an exact representation of the data. It's kind of a smoothed over, more perfect model of the data. So it is a representation, a close representation of the data, but not exactly. So we call this a mathematical model. And so mu is the mean of the model. This is sigma, and of course sigma would be then the standard deviation of the model. So we use Greek letters usually when we're dealing with models, and English letters when we're dealing with the actual data. And then we will build on this later in the next video and talk more about this, what this is called and what we use it for. Right now, think of it as a type of density curve.